vehicle market, you've probably heard a lot about.
Cobalt.
The reason cobalt's been getting so much attention is because it's one of the metals used to make lithium-ion batteries, which power everything from laptops and cell phones to electric vehicles. The amount of different metals found in an EV battery can vary depending on the battery type and car model, but a typical lithium-ion battery pack may contain around 14 kilograms of cobalt. Cobalt has been a popular choice for batteries because the metal increases battery life and energy density, which in the case of EVs means range, by keeping the battery structure stable as the battery is continuously charged and discharged. But cobalt, which is usually extracted as a byproduct of nickel and copper mining, is one of the most expensive materials in a battery. While battery prices have fallen 89% between 2010 and 2020, they still make up about 30% of the total cost of an electric vehicle. Cobalt extraction is also linked to human rights abuses and child labor. These are some of the reasons why battery manufacturers like Samsung and Panasonic, and car makers like Tesla and VW, along with a number of startups, are working to eliminate cobalt completely. But although there are a number of different cobalt-free technologies being tested, each has presented its own challenges. EV sales worldwide are expected to skyrocket from 3 million in 2020 to 66 million in 2040. And with increased demand for EVs, demand for raw battery materials like cobalt is expected to outstrip supply.
Comparing demand and supply for cobalt, there is, geologically speaking, enough raw material in the Earth's crust. Same with lithium, same with nickel, same with manganese. It's just that the production and the processing of that material, just like all the other materials, is nowhere near the level that it needs to be to sustain the level of demand.
One way to ease demand for new cobalt mining is by recycling the cobalt found in old batteries. But some types of recycling have downfalls.
Currently, cobalt is recycled, but the process in which it is recycled is very environmentally unfriendly. You take old batteries and you smelt them at temperatures higher than 1000 C, and you can extract the cobalt back out of it. The reason that that is done is because of how expensive cobalt is.
For the past 4 years, the average cost of cobalt was more than the cost of all the other battery metals put together. The price of cobalt has also historically been very volatile. Part of this volatility may be due to the fact that cobalt is usually produced as a byproduct of nickel and copper mining, and therefore tied to the demand and price fluctuations of those metals. The mining and refining of cobalt is also geographically limited.
The majority of the world's battery-grade cobalt reserves are located in the Democratic Republic of Congo, where the mining of cobalt is associated with human rights abuses and child labor and so on.
Chinese investors control about 70% of Congo's mining sector. China also has over 80% control of the cobalt refining industry, where the raw material is turned into commercial-grade cobalt metal suitable for use in EVs. In light of the US-China trade war, cobalt supply is in a precarious position for US manufacturers.
There is already a viable cobalt-free battery, and that is lithium iron phosphate, or LFP. But the main downside of LFP is low energy density and therefore driving range. Notably, it's a lot cheaper. The component materials are a lot more readily available and abundant than nickel and cobalt, and it has a longer longevity.
Lithium iron phosphate batteries are also generally considered very safe, since iron is a very stable element. Ford and Volkswagen have both said that they would offer vehicles with LFP batteries. Tesla already uses LFP batteries in the Model 3 and Model Y vehicles it manufactures in China, and the company says it will now expand use of LFP batteries to all of its entry-level Model 3 and Model Y vehicles. Even Apple was reportedly in talks with Chinese LFP manufacturers to make batteries for its planned EV car project. In an effort to reduce US dependence on foreign countries, the US Department of Energy released a national blueprint in June to help guide investment to develop domestic lithium battery manufacturing and support further R&D. Among its goals, the blueprint calls for eliminating cobalt from lithium batteries by 2030. Although cobalt-free battery performance continues to improve, experts believe that the future EV battery market will consist of a number of different battery chemistries for different applications.
We calculate around 20% of the global battery electric vehicle market by 2030 being taken up by these new cobalt-free chemistries. We expect that the sort of entry-level low-cost vehicles For example, the standard range model, Tesla Model 3, will be LFP or lithium iron phosphate, and then followed by these cobalt-free materials, which will account for most of the mainstream volume vehicles. And then at the top end of the range will be high nickel batteries, which will account for high performance, high range vehicles.
Other battery breakthroughs could help enhance cobalt-free chemistries. Car companies Hyundai and Kia announced they're working with US-based Factorial Energy to replace liquid electrolyte batteries with solid-state electrolyte batteries. This would give batteries an even longer range and added safety benefits. Meanwhile, others are focused on improving the battery's form. But whatever advancements we make, experts stress the technology needs to be widely accessible. If you've been following the electric vehicle market, you've probably heard a lot about
Cobalt.
The reason cobalt's been getting so much attention is because it's one of the metals used to make lithium-ion batteries.